Now, I'm going to go ahead and put the two questions up. There, let me just put it to you this way. 90% of the questions are what I would put on a test, but I am not going to test you on residuals. So I need you to write that down. I'm not going to test you on residuals because I really feel that since with technology, really there's no reason to, but I'm going to show you how to work with the residuals. All right. So the first question that we got is 4.117/6. This is not residuals. This is just 4.117/6. And I don't know why it didn't pull up, but I'll pull it up again. Now, I know some of y'all are sitting in the middle to the back, so I don't know how you're going to see it, but it's up to you. Here is the question. And the question says, for the accompanying data set, draw a scattered diagram, find the correlation coefficient, and determine whether there is a linear relationship between X and Y. Now, before I start the problem, I don't know if I mentioned this to y'all. I can't remember because I've got 3 different 120s. I think I told y'all. When you are testing a correlation, when you are testing a correlation, they will give you a table of critical values. They will give you a table of critical values based on N. So if you have 5 points, you look at N is equal to 5. If you have 10 points, you look at N is equal to 10. If the absolute value of your correlation coefficient, R, is greater than the critical value, you have a correlation. Now, did I tell you all that the other day? I can't remember. This is from 4.1 and 4.2. So I can't remember if I told y'all that or not. So I want you to write this down. I want you to highlight it. If you calculate the R, and if you take the absolute value of R, and it's greater than the critical value, which is in the table, then you have a correlation. If it's not greater than, then you do not have a correlation. So what I'm going to do, I'm going to do 4.117/6 and show you how this works. Here is the data set. So I'm going to put it in the Excel spreadsheet so you can see it. And I guess it's the one I just pulled up. And this is the spreadsheet. Let me make it bigger and so y'all can see it. I think you could probably see that. So go ahead and put those in your calculator. Okay. Now I want you to go ahead and in your notebooks, I want you to plot these points. In your notebooks, I want you to plot these points. I'm going to plot them. I want you to plot them also. So 2, 1, 2, 1, 2, 3, 4, 4 and 8, 4, 5, 6, 7, 8, 6 and 10. So that's 4, 5, 6, 10, 6 and 13. And 7 and 20. So that's way up there. So you got 5 points that look like that. So you're probably going to have some kind of line that looks, I don't know, like that. So if you've got your Excel spreadsheet, you can just highlight those 2 rows, go to Insert, go to Charts, and hit the chart plot. And there is the scatter plot of this question. Now, if you take the right click button, add trend line, and hit display and display, there is the equation for the line of best fit. And R is going to be equal to the square root of 0.8025, which is, which is 0.8958. So what you've just done, you have just done everything that I want you to be able to do on a test. Okay. So y is equal. Please tell me that that's my voice I hear and not things outside the classroom or inside the classroom. Y'all don't hear any noises, do you?
No, sir.
Right, I hear noises again. 2.6875x minus 2.4375. R is equal to 0.8958. So if you look at this piece of paper right here, that is pretty much what I want you to be able to do. But there are some homework problems that ask you to find the critical value. Not this one, but yeah, it does. I think it does for the SU2. So now let's go back and see what they're going to ask for, the critical value. And N is equal to 5. We've got 5 points. So now we're going to go back to the critical value. Click here to click for the critical values. And what is N is equal to 5? Point what? 0.878? .878. So critical value is equal to 0.878. So the homework is going to ask you, is this a correlation? Well, 0.8958 absolute value is greater than 0.878. Therefore, this is a correlation. So that's what some of your homework questions are going to ask you. Now, did we cover this before, the critical value? I don't think we have we?
No, sir.
I don't think we have. So make sure you understand. Now, what if you have a negative correlation? Well, that's why it's got the absolute value. If you have a negative correlation, I'm going to show you on the next page. Let me make sure, does everybody understand this problem? Does anybody have a question on this problem? Y'all have enough? Do y'all know that Palmetto High School, the other class I teach, there's only one person in the classroom now?
They dropped it?
They don't have it. They're just on quarantine. You know what I think? I think they're just saying that they're on quarantine just so they can stay at their house. A whole class, 15 people. There's only one left in the classroom. All right. So now look at this. What if I have this question? What if I have 1, 2, 3, 4, 5, and I have correlation negative 0.98 equals R. All right, let's say you're doing a homework problem and this comes up. Well, n is equal to 5, therefore 0.878 is the critical value. And then you take the absolute value of negative 0.98. Is that greater than 0.878? What is the absolute value of negative 0.98? 0.98. Is 0.98 greater than 0.878?
Yes.
Yes. So therefore, you have a negative correlation. So whether it's a negative slope or a positive slope, you're still going to say this at the end, but this is a test. You're testing the correlation coefficient R against the critical value. Okay, now that's it on that question. So let's go back to the test question. That noise is driving crazy. Go back to the test question. And which one did it look like? Let's see. It looked like, it kind of looks like that one. That's not this one. Why is it? Let's see which one it's not. Somebody tell me which of the 4 graphs, there's 2 of them that it can't be. Which one is that?
A and C.
It can't be A because that's a what?
Negative slope.
That's a negative correlation, and that's a negative correlation. So if you say that A and C is the answer, that just tells me that you don't know what you're doing. Okay? It looks like it's either B or, I'm trying to look and see what the difference is. I don't really see a difference, except these 2 are closer to each other. So let's see, that's 6 and, hold on a second. I don't have the points in front of me. So I don't have the points in front of me, so I need to go get them. Hold on a second. Let me get my mouse back. There we go. Now I got my mouse back. So 6 and 10 and 6 and 13. So that's pretty close. So I'm going to go 6 and 10. Each one of these is what? 2, 4, 6, 8, 10, 12. It's B. Oh, okay. I didn't see the check. The answer is B, as in Bravo. Okay, the correlation coefficient is 0.896. Good. And because positive, okay, so 0.878 is what you got in the table up here for 5. Okay, so that is a test question. I don't mind putting that on the test. The only reason I don't like residuals is because, to me, they really don't tell you anything. And with the technology, you really don't need to do them. But we're going to go ahead and do one anyway. So that's that question, and that is a test question. So make sure you can look up stuff on the table. Just find the n. In this case, the n was 5. So it'd be the critical value is 0.878. And that's what you're going to put your correlation coefficient up against. All right. So let's do another one. And let's do that question that has the residuals on it. And let's go to the homework. This is 4.2 7/3. 4.2 7/3. Now it's going to have a table just like the first one did. I mean, not a table, but thing of points. So let's just do this A, B, and C. I'll go ahead and open it up in Excel so I can make it bigger so you can see the points. I want you to take these points and I want you to do everything you can that I've taught you so far. I want you to do everything you can in your calculator or Excel spreadsheet. And there you go. So go ahead and do whatever you can do with your Excel spreadsheet or your calculator and do as much as you can for these 5 points. I'll give you a couple of minutes. That means Miss Simpson and Miss Vaughn, y'all's video's not working. I guess not. That's why I don't like when people don't turn them on. You don't know if they're watching, you don't know if they're paying attention. So now I'm going to add a couple of things to this. In fact, I'm going to make this one a little bit bigger. Well, no, actually, I'm going to insert. And I'm going to make this one bigger. Okay, if you plot these, you're going to get insert. You're going to get a chart plot that looks like this, or a scatter plot that looks like this. I want everybody to put in your notes that you just plotted the observed points. Write that down. You just plotted the observed points. In other words, each one of these points is a single piece of data, and you just plotted the observed points. 2, 2, 3, 5, 4, 10, 6, 14, and 7, 17. Those are 5 individual points that you have plotted on a graph. Does everybody understand that? They're like observed. They're like, you know, there's nothing going on. You just wrote down the data and you put it on the chart. Okay? I would ask Miss Vaughn or Vaughn and Simpson if they understand, but I don't know if they're even looking. I don't even know if they're in the room because their video is not turned on. So, does everybody understand that? Now, I can draw a best fit curve, and we can do that right now. Right click, add trend line, and display, and display. Does anybody have any idea how to explain that line besides that it being the best fit? Can anybody explain that line in layman's terms? Anybody? It is what we call a prediction. Write that down. This line is a prediction. This is your prediction line. Let's say that your X here is, I don't know, the number of years you've been working at a place. God, freaking sound is so annoying. Number of years at work. Number of years at work. And let's say that the Y is equal to amount of money put in, we'll just make it up, just amount of money in IRA. Okay? I'm just making up something just so you can understand what's going on here. Okay, so the Y is the amount of money that's put in your NRA. It could be by the thousands, it could be by the hundreds. And this is number of years at work. Everybody with me? Yes. And these are actual. Now, what does the best fit, what does the line do? It predicts. What do you mean predicts, Hubert? Well, I want somebody to plug in 2 in the regression model, which is right there, and tell me what you get. I'm going to plug in X hat, Y hat. Well, X hat, you don't really have an X hat, you just have an X. And that's 2, 3, 4, 6, and 7. And I'm going to plug that 2 into our equation. 2.9535 times x, which is 2, minus 3.3953. Now, somebody tell me what I just calculated the what values, the predicted values. These are the points on this line right here. This point right here, I'm going to try this. Hold on just a second. I don't know if this is going to work or not, but I'm going to try. Let me get a translucent and that. Make this a little bit bigger. I'm going to try this. This point 2 right there. That point right there. That point right there. That point right there. And that point right here. Now you can't see it except for the one in the middle. But what is this area? And I'm going to take my highlighter again. And I want you to try to put those points on your graph. And I'm going to try to do it here if I can find the way to do it. Hold on. Okay, here we go. And I'm going to make it a little bit thicker. These yellow areas right here, can anybody tell me what they represent? And you can't see them really because, so you can see the middle one right here. And this one right here. Okay, the yellow marks, can anybody tell me what those represent?
Standard deviation.
No, but that's a good guess. Never thought of it like that. It could be, yeah, you could actually say that, but that's not the right answer. These are called residuals. Write that down. The yellow area, the yellow line between the blue point and the magenta point, they're called residuals. What happens when you eat a big hamburger with a lot of mayonnaise, a lot of mustard, a lot of ketchup, and a lot of tomatoes on it? What happens when you bite into it?
Falls out.
All of it falls out on your shirt, right? Or wherever you're eating. That's called residual, right? What's left over? I'm sorry, you don't know how annoying that sound is. Okay? Left over. What's left over? Was that supposed to be funny? I'm sorry. I forgot to laugh. Which one's the comedian? Is it the Unabomber back there? Which one's the comedian? I want to know at least who the comedian is.
You.
He's
Yeah.
the
The one that hides. Yeah, I know. All right. So anyway, the residual is between. Somebody tell me. Look at the. Let me get out of this and get rid of the graph. I'm gonna cut the graph out. Somebody tell me, what is the definition of residual? By the yellow line. Say again.
Left over.
Between what?
1, -1.
Well, I'm actually wanting you to use the words that are on the spreadsheet here.
The distance between the predicted values and the observed values.
That's it. That's exactly right. Write that down. The residual is the, we'll have a nice office one day while other people are going to be taking out the trash. All right? Residual. Residual is the difference between the observed value and the predicted value. So write that down, please, and I want you to form a table, a column, and I want you to actually do that, please. I don't know how that happened. Hold on a second. Let me redo that. There we go. And you can put y minus y hat. Y hat means, let me show you what y hat means. This is y hat. Y hat is the predicted y. That's why I call it y hat. Anything in stat with a little caret symbol on it, K-A-R-E-T, caret symbol, is a predicted y. Now, sometimes they will ask you to graph the residuals. They will ask you to graph the residuals. So what do you do? Well, you use these X's right here. Use those X's. I will highlight those X's yellow. And you will use these points right here and graph those 2 points. So I'm going to go down here. And I'm going to make this a little bit smaller. And I'm going to make another thing right here. 2, 3, 4, 6, and 7. And then I'm going to put these points right beside it. And then we're going to graph those. So I'm going to graph those. I'm going to go to Insert and Plot. And that's what they look like. So I'm going to draw a little graph of that. I don't know where that came from. So 1, 2, 2 is a negative, 3 is a negative, 4 is a positive, and 5 doesn't exist, and 6 is a negative, and 7 is a negative. You could say 7 could be a positive, but anyway. Now, does that tell me anything? No, not really. But that's what they want. They want, for some reason, there's some questions in this homework that wants the residuals graphed. Sometimes they will ask you to square the residual and add them up. Again, do I agree with that? No. But I'm just telling you what the homework says. So I'm going to put R squared right here, not R squared. I'm going to put RES squared because RES, R is the correlation coefficient. I'm going to put RES and that's going to be equal to that number squared all the way down. And then they want you to add that number up. I don't know why. There you go. It's called the residual squared. The residual squared, in this case, is 3.16. 3.16. Now, again, one of the reasons I'm giving you this information is not because I test you on it, it's because it's in your homework. So if you go to your graphing calculator, let's go there now. And I'm going to go and put in these stat, edit, and I can't remember, so I'm going to make it smaller. 2, 3, 4, 6, 7. So annoying. Two, 3, 4, 6, 7. And the other points 2, 5, 10, 14, 17. 2, 5, 10, 14, 17. Has everybody got those typed in? Now, you can actually go and do your stat, calculate, linear regression, take off the frequency list. So I don't know why they have that in there. Take that off. And calculate. And there is linear regression and the R value. Now I'm going to show you how to find the residuals. Okay, you ready? Here is the residuals. You hit second, list, and there are your residuals. There's the residuals. Now you can put them in your stat list by doing the following. It's stat, edit, go and highlight L3 and put in second, list, and type in residuals and enter. Does everybody see that? Now you can do anything you want. I'll show you how to square them. Go to L4, type in L3. You can hit shift second, L3, raise to the second power, enter. Does everybody see that? Because I see half of y'all looking down and I see half of y'all need something to tell me. Are you working? Do you understand? I see a couple of people, I think they're understanding. Again, Miss Vaughn and Miss Simpson don't have their video's on, so I'm probably not gonna count them for being here today.
They do have.
They have to.
Oh, now we get some discussion. Okay.
Can you see us?
No, we can't. I can't see you. Evidently, something's not working.
Okay.
All right. I figured that would get a little bit of interaction once I said that. Next. Anybody got any other questions on this? Nobody has any other questions about the residuals? Okay. All right. Well, I went ahead and showed you how to do it, so I don't want your belly aching. Let's go back to, did we get to probability? Did we start talking about probability?
We did a little.
Okay. How far did we get?
Pretty far.
What was the last thing you got in your notes about probability?
We talked about, looks like cause and effect.
Yeah.
I'm sorry, say again?
Looks like we said something about cause and effect,
Yeah, that thing is
the causality.
Causality. Okay.
That's the one.
Did we talk about sample spaces?
I don't think so.
Okay. All right. Well, that's what we'll talk about, and that'll finish 5.1 once we talk about that. So hold on just a minute. Let me get to the. Okay, so here we go. A sample space. I'm going to pull up a sample space is the number of outcomes that can happen. Write that down. A sample space. Number of outcomes that can happen. I'm going to give you 4 examples of the number of outcomes that can happen. And I'm just going to Google sample space children. Now, if a couple decide to have children, to have 2 kids, if they decide to have 2 kids, what is the sample space for 2 kids?
Like the gender,
Yes. What is the sample space?
there's gonna be a minute, hold on.
Boy, boy,
Yeah,
boy, girl,
yeah.
girl, boy,
Girl.
and girl, girl. Now, you need to write that down because this is going to be a test question. Now, what I tell students to do, and only 4 or 5 of y'all are going to do this, you get an index card and put the 3 sample spaces for children on the back. This is your first one. This is 2 children. 3 children, and I'm going to show you those on the sample space because it's easier and quicker to have them on your index card rather than trying to figure it up. And here are the sample spaces. So I'm going to send these to you for the 3 people that are actually going to do it. And let's find 3. Here's 3 children. And I'm going to copy that. Copy image. And I'm going to send that to y'all right now. You can use it if you want to. So I'm gonna send that. I can't send a picture. Okay. Let's see if I can send a file. No, I can't. Let's see if I can Control V.
I heard it chug chug.
There we go. See if you got that. Can you see that on the screen? I just sent it to y'all. Yes or no?
Can you repeat that?
No.
I'm not.
What did?
See, that's another reason I wish y'all were on your. Okay, I'm gonna send you another one. That's gonna be 4 children. Or yeah, that's 3 children. This is 4 children. And Control V. Do you see those? I'll just bring them up on the screen. Just hold up. Hold on. I'll do a word processing document. Okay, let me do Control V. Or paste, it should be Control V. And do the one before that. Function V. And I don't have that. So I'm going to have to go copy it again. Give me a second. I'm trying to send this to y'all, so just hold on. You're welcome.
Thank you. Thanks. What's the gargle?
No.
How we gargle?
That's no money.
That's what we said.
Give me a second. I'm still copying. Hold on.
You said 2 was
No, I see.
I heard it.
Okay, this is the one on the board. I don't know if you can see it, but I'm showing it to you. This is 3 children. And this is 4 children. Now, what I would suggest you do for the 5 people that's going to do this, make sure you put it on your index card. You want 2 children, 3 children, and 4 children. Okay, another one that you want for a sample space. 2 die, or a pair of dice. And I'm gonna look that one up for you and send that one to you.
2 die?
2 dice, a pair of dice. Space. Dice. And this one's pretty self-explanatory. Like I said, for the 5 people that's going to do this.
Flat tire.
And I'm going to save this as a Word document. I'm going to send it to y'all. I'm going to send it, hold on just a second. We'll call it sample space. And I'm going to send that to you. So that last test, do you think that last test was pretty fair?
Oh,
Yes.
yes.
You should do
Okay, do y'all want me to keep being fair?
Yeah.
Yes, sir.
Okay, I'm just mentioning that, because I could be unfair. Yes, ma'am.
Are all the tests not gonna have stat crunch?
Some questions do, some questions don't.
Okay. Yeah.
Okay, the ones that need it, they will have it. The ones that don't need it, you can use Excel, you can use your Google, but I don't think it'll let you use Google since Google is not Excel.
Like,
So on the test, you're either going to have to use your TI, you're going to have to use the StatCrunch, or you're going to have to use Excel.
TI 84? Or 85?
Yeah, TI.
Yeah.
Okay, I just sent you, so Miss Vaughn, Miss Simpson, did you just receive those two pictures, and did you receive the document?
I don't know about the document, but I can see them in the chat.
Yeah, I just sent a document too. I'll check it now.
I'm not seeing anything. Oh, there it is. Yep.
Okay, you got it. So everybody has those two pictures and the document that I just sent. Does everybody understand that?
Yes, sir.
I would highly suggest that you cut them out, copy and paste them onto an index card and use that for your test. Now, the good thing about I'm going to show you this. Going back to this one right here. What else do you think you can use with this one? What else has a 0.5 probability? What other example do you know has a 0.5 probability?
Any yes?
Besides boy, boy, girl, girl. What?
Any yes or no question?
A yes or no question? Yes, yes, no, yes, yes, no, 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 yes. What else?
coin.
Coins. Heads, heads,
Tails.
tails, tails, heads, tails, tails. So these are sample spaces. So if I ask you, if you're flipping a coin, what is the probability of getting, if you're flipping two coins, what is the probability of you getting both tails? And that would be 1 out of 4. 1 out of 4, which is equal to 0.2425.
Yes, it is, because according to my research, you're supposed to start running at 252, and what's it doing? Running at 252. So call me John. Yeah, can you?
What are y'all talking about?
It just got very windy here, so we were asking if it was raining.
Oh,
And then somebody wanted to answer the question, but nobody was talking about it.
all right, whatever. All right, now, I'm going to ask you a question that's on a standardized test, and people miss it. And it's on my test, and people miss it. What is the probability of rolling a 7 on a single die?
Wait, people missed that?
0%.
0. Listen, we have people, I have people, one of my college classes, I had 4 people miss what branch of service was I in.
How did they not remember?
I
No
did.
states were in.
I did.
Yeah, I literally studied.
I had one person miss the phone number and email address.
Yeah, I actually put one in the
So what is the probability of 2 even numbers on a die?
2 even?
I'm just sorry, of even numbers, of rolling an even number on a die.
50%.
3 out of 6, which is equal to 0.5. What is the probability of rolling I'm not rolling, of picking a king out of a deck of cards.
4 out of 52.
There is
4 out of
52.
52,
Either.
which is equal to 1 out of 13.
Oh my God.
Okay? Now, all of these things that I just gave you, all of these examples, this is theoretical.
I hate this.
Theoretical is based on what you know.
He wasn't lying.
Huh?
Two is titties.
The what? What? There you go.
Theoretical is based on what you know. There's nobody in the room that had a deck of cards or a single die. Nobody rolled a die. Nobody, you just know. That's called theoretical probability. What is physical probability?
It's when you actually do it.
You actually observe, yes.
Yes.
Physical means you actually observe. And that would be rolling a die 7 times and getting 1, 6, 1, 5, 2 4s, 1, 3, and 1. Let's see, what is that? 6 and 1, 2. So the probability of rolling a 4 would be 2 out of 7. Now, I don't know if we covered the large number rule. I think we did. But the physical probability will not always equal the theoretical probability. Unless you bring in the law of large numbers. And the law of large numbers brings the physical probability closer to the theoretical probability. That's a test question, so make sure you know that. The law of large numbers brings the physical probability closer to the theoretical probability. So in this section 5.1, you need to be able to do 3 or 4 things. You need to be able to distinguish between physical probability and theoretical probability. That's one thing you got to be able to do. Okay, so one thing is to distinguish between physical probability and theoretical probability. You got to know, number 2, you got to distinguish between an event and sample spaces. Meaning, what is the probability of a boy being born?
50%.
0.5. What is the probability of all boys? What is the probability of all boys with 3 children? 1 out of 8. You got to be able to know the difference between just one event, like the probability of a boy, and sample spaces. And you got to know the law of large numbers. Which means you get out what you what?
Put in.
What you put in. If you do not put in a lot of work to your research and get a lot of surveys or a lot of whatever, a lot of samples, then your research is going to suck. Your statistics will suck. Y'all are working on unfair tests. Y'all are really working on unfair tests. And I don't know if it's the Unabomber or Mr. Joker, but y'all are ruining.
Can you clarify?
They're the same person.
No, we're different.
Definitely not.
Can you clarify Unabomber and jokes?
I'm not going to say a word. I'm just going to stay quiet because
It wasn't God.
I know most of y'all are going to have nice jobs.
Right?
Next,
Nice job, appreciate it.
why some people be cruising the mall at 40 years old. All right. So in 4.1, 4.2, 5.1, that's what we've gone over so far.
Wait, that was
4.1, we talked about correlation, causality, 4.2, we talked a little bit about residuals, and you're also going to have some slope and equations. In 5.1, we brought in probability. Single probability, meaning with one event or one sample space.
Is it raining?
Yep.
Guess we're inside again.
We're looking over the tree.
Sorry, that's,
Is it coming down?
Y'all be quiet. I have a question.
Then ask it quickly.
I will.
Okay. Any
So,
questions?
Yes, on the homework, you have 4.2 as due today. Was that on purpose or was that on accident?
I'm going to extend that because I just went over the residuals. I'll fix that.
All right. Thank you.
So it's not.
No.
It's not.
That's really nice. Thanks.
Okay. Anybody got any questions?
That's not a project.
We got one more.
Yeah.
Unabomber wants some. Jokester.
So, I submitted my test or I never submitted it, so now it won't let me do the homework. And it says you gotta fix it for me, so I'd be able to do the homework.
You didn't email?
So it locked down. Does that mean you went out of the test?
Yes, sir. I like to shut my Chromebook
On his third try.
on my third try.
All right. Hold on, and I'll fix that after class.
Okay, thank you.
Yes, sir. Any other questions besides those two? Okay. Is everybody here? How many are in the classroom? Because Miss Vaughn and Miss Simpson are calling from home.
Yeah, we got everybody.
All right. I need the person, the Unabomber. I need him to come up and give me. What's your last name?
Mommy.
Oh, Benninger. I sent you an email.